So welcome back to another video where I'm covering substitution shortcuts which you can use to save a lot of time on your IB Math HO paper. So yeah, here we're going to be looking at the integral of x by x plus 1 dx. This function is a rational function, and if you guys don't know what a rational function is, well, it's basically any function that can be written as a polynomial divided by another polynomial whereby the denominator is not equal to 0. So now you guys need to know what a degree is. The degree of any polynomial is the power to which it's raised. So the degree of x is just, well, 1, because this x power 1 is equal to x. So yeah, the degree of x is equal to 1. Degree of x squared is equal to 2. The degree of x cubed is equal to 3. So to use this shortcut, all that we need to do is make sure that the highest degree in the numerator is equal to the highest degree in the denominator. So we can see that over here this sum satisfies that, and therefore we can use the shortcut. For example, if the sum was something like this, where the degree of the numerator is less than the degree of the denominator, well, you cannot use this shortcut. Instead, there's another shortcut which you can use, and I have made another video regarding this, so I'll leave the link in the description. Go check that out. And another situation would be if the degree of the denominator was 2 greater than the degree of the numerator, then you can't really solve this by hand, and you should probably be looking to use a GDC. As soon as you see the sum, you can notice that degree of the numerator is equal to the degree of the denominator, and therefore choose this shortcut and we proceed. So let's first look at how you would regularly solve a sum like this using, well, regular substitution. This is the sum. Well, I would substitute u as x plus 1. So you guys might be wondering why I chose u as x plus 1. Well, our aim when solving any substitution sum is to choose a value for u such that later in the integral all the x terms are eliminated and we're only left with, well, u terms. If we take this, later you'll notice that all the x terms are negated. So we have u is equal to x plus 1, and we solve du by dx, we get 1. So du is equal to dx. So this can be written as, if you substitute the u terms in, x by x plus 1 to du. Here we can see that we can't really cancel out the x terms here, so we're going to convert the x terms into u terms. So to do that, we can write this equation here in terms of x. So we get x is equal to u minus 1. So we can write this as u minus 1 by u minus 1 plus 1 du. So this would be equal to the integral of u minus 1 by u du. And now we can further solve this sum. U by minus 1 by u du, and then we can simplify this further as 1 minus 1 by u du, and we would get u minus ln the natural logarithm of u plus c. We can substitute u back in and we get x plus 1 minus the natural logarithm of x plus 1 plus c. So this is our solution. You can see this involves quite a few steps for what is a very simple integral. We should be looking to shave off time in sums such as these so we can focus our efforts on the much more demanding sums. So let's look at the shortcut. So this is something you probably didn't look at, but yeah, it's a very simple tweak. So we can write this as x by x plus 1, and what we can do here is just plus 1 minus 1. As you probably noticed, the plus 1 and the minus 1 would cancel itself, so these two are still equal. So now we can just split the fraction up, and we would get x plus 1 by x plus 1 minus 1 by x plus 1 dx. So this would be equal to 1 minus 1 by x plus 1 dx. So as you can see, we achieved this in roughly 2 steps, whereas when using the full version of this, we took so many steps to arrive back here. And while doing the full version, we obviously probably spent some time thinking about what to substitute in. And if we did substitute the wrong equation, we probably had to do the sum again. So yeah, this will surely save you a lot of time. You're not going to make the mistake of substituting in the wrong value of u. So now if we go ahead and solve this, we're going to get x minus the natural logarithm of x plus 1 plus c. So here we are, we have the solution. So if you guys notice, this solution is not the exact same as this solution because of this plus 1 here, but not to fret, because basically over here, if instead of taking plus c, we can just make it plus d, and we can then assume that d is equal to 1 plus c. So when solving integration sums, always notice that there will be different answers and the examiner will give you marks for the different answers. Since this is really an unknown constant, it does not matter if there's a plus 1 or a minus 1 to the unknown constant. The constant is still unknown. Therefore, this answer is still correct and your examiner will give you marks. Thank you for watching, guys, and I hope this shortcut will help you save a lot of time in your IB Math HR paper, and I'll be back with a lot more shortcuts to help you achieve better grades. Thank you.